All right, on our second one.
How long is this one going to take?
It's twice as many problems.
Okay.
Okay, so we're going to look at FOIL with this. Now, sometimes you'll FOIL and just be done. Other times you'll FOIL and then look to simplify. This first one, all we'll do is FOIL and be done. Okay, so what's 1 times 1? 1. Outers is minus cosine of x. Inners is plus cosine of x. Last times last is minus cosine squared of x.
Whoa. Yo. Little slower. Let me take that in real quick.
First times first is 1. Then we do outers. 1 times negative cosine of x. It's negative cosine of x. Inners is positive cosine of x times 1. Last times last is positive cosine of x times negative cosine of x, which is negative cosine squared of x. What happens to our middle two terms? Negative cosine of x plus cosine of x cancels. So it's 1 minus cosine squared of x. Now, we could, if we wanted to, simplify that one more time. Because that's like a Pythagorean identity. What Pythagorean identity is it like? Sine squared of x plus cosine squared of x equals 1. If you subtract cosine squared from each side, what do you have? Sine squared of x. That's what that winds up to be. Okay? And we go, where did you pull the sine squared of x out of? Well, I pulled that out of the Pythagorean identity. All I did was subtract cosine squared of x from each side. Okay? The second one. Is there anything that's not a sine or a cosine at the start? There's a cotangent in there. So I'm going to rewrite this with cotangent as what? Cosine of x, or b in this case, over sine of b. Okay, in the numerator, what can I do? Multiply the denominator times what?
I don't know, man.
No. Isn't this a multiplication problem? With something in the numerator and something in the denominator that are the same, so they can cancel. Boom, boom. So this is really cosine of b plus 1 times cosine of b minus 1 all over sine squared of b. What do you think I can do now in the numerator? FOIL. Because there are two binomials right there. So let's FOIL. Cosine times cosine is outers. Inners. Last. What can I do with my minus cosine of b and plus cosine of b? And what is cosine squared of b equal to? Cosine squared of b minus 1. Sine squared of b. And what's sine squared over sine squared? 1. So this whole mess of a fraction simplifies all the way down to be 1. Now, will that happen every time? No! Not everything cancels to be 1. Okay? It's just fairly frequent in trig. Okay, so that's the first 6 problems of your assignment will look like that. The last couple will look like this. We're putting one function in terms of another function. Okay? So if I want sine x to be put in terms of cosine of x, I want to get sine of x alone on one side of the function. So to get sine alone on one side of the function, I write the Pythagorean identity at the start. Sine squared of x plus cosine squared of x equals 1. Then to get sine alone, I just subtract cosine squared and take the square root of each side. And then when you take the square root of two sides of an equation, you negative plus or minus. So sine of x equals positive or negative the square root of 1 minus cosine squared of x. Okay? You guys can follow that, right?
Yeah.
Use a Pythagorean identity and get whatever you need on one side alone. So now I want to do cosecant in terms of cotangent of x. What's the Pythagorean identity of cosecant and cotangent? We have a Pythagorean identity for that. Cosecant squared of x equals cotangent squared of x plus 1. Boy, it's almost ready for me. What's the only thing I have to do on both sides? Take the square root. So cosecant of x equals positive or negative the square root of cotangent squared of x plus 1. And that is it. I stop right there because I have cosecant in terms of cotangent. Cosecant is alone on one side of the equation. Your second assignment is 1 through 18 all, or 11 through 18 all on page 165. So same page. You did 7 through 10 on the first one. Now you're doing 11 through 18. You should not have a problem getting this done within